Thank you. Thank you. Thank you. All right, couple of quick things. First off, this was due yesterday, and I forgot to ask Miss Courtney to collect it. If you don't have it ready today, which no one in first block did either, you need to get it done during enrichment. You need to turn it in after third block or after enrichment. If you don't have, if you leave after this class, stay after this class and finish it quickly. It's 3 questions. Now, I want y'all to get out your textbook and look at M1-152 quickly, because a very intelligent student in first block did not use his brain and was like, Mr. Kinney, I have no clue how to do these things. So I want you to look at M1-152. Yes, it will help you significantly. So, 2 quick things. We're going to talk about some of these details in class, some of these details in class. We haven't used this term general form very much. What do you think is another way that we might say general form? Standard. That's just standard form. Okay. Now remember, I never asked you to write standard form. So you need to pay attention to how I might rewrite that in standard form. First off, what does it mean to square something? Use that to help you figure out what it's supposed to be in standard form. Okay? We'll talk about some details with number 4. But number 2. Okay. Queena is saving money for a new bike. I'm going to make up a different number. Let's say she has $3 in her savings account as January 1st. At the end of each month, starting with January 31st, she is planning to add to her account a number that is equal to the amount in her account. So if she has $3 January 1st, how much is she going to add to her account? No, sorry. I'm not using this 5. I'm making up a 3 for her to start with. So how much is she going to add? 3, right? So how much does she, and she's going to add to her account an amount that is equal. So if she adds 3, how much does she have now? 6. At the end of the next month, she has 6, so how much is she going to add? 6. So how much will she have? 12. Okay. Now, I want to pause, and I do want to remind you of something. Is there a mathematical representation that can help you organize and keep all this information straight? Okay. Use your mathematical representations. Because if you do, this question becomes very simple. So, month 0, she has $3. Month 1, she's going to have $3 more or 6. Month 2, she's going to have $6 more or 12. Month 3, she's going to have $12 more or 24. What is mathematics?
Patterns.
Study of patterns and relationships. You should be able to find a pattern or a relationship there to help you answer all of those questions. Are we clear on this? Nope, just 2 through 4. Yep. That is what is due to me today. Yeah, so there it is. We're not doing this in class though, because we have other stuff to help you all get ready for your exam that's on what day? Friday. I'm going to look at your bell ringer in just a second, but I do want to look at the agenda first before I forget to do this. Makeup work. This isn't as big of an issue in here, but you'll know what your grade is in my class somewhere between Friday and Sunday, depending on when I get the exams fully graded. My exams, just like my tests, are free response for the most part. So, it will take me time to score them. I'll send out an email when I'm done scoring them. You will be able to see your grade in Power Schools. If you don't love your grade, you have makeup work. I don't give out bonus points, but you have makeup work, probably. There's no one who's failing or has a D or has a C that doesn't have something that's a 0, okay? So, if you want to email me, I will let you work on makeup work over spring break, and I will bust my butt to get it graded and into the grade book before the Wednesday after spring break, because that's when grades are due. So, if you have 0s, Get rid of those zeros. An assignment is 10% off every day it's late, which is why you need to pay attention when things are due. But, yeah, you can still get a 50, is essentially what I'm saying, which is way better than a 0. Now, for a handful of us, and I may be misremembering this, but Xavier, I don't think you did a bunch of the homework, or most of the homework, right? But what'd you make on the test? A B. So what happened to those zeros? They went away. I didn't even replace them. I just took them out. I'm okay. Like, if you can make an A or a B without doing the homework, kudos to you. Did you still learn? Heck yeah. But the homework is designed, ladies and gentlemen, to support your understanding. The graphic organizers are designed so that you go back to your notes, you reflect upon the things that we did, not just write down a sentence to copy it over, but reflect on what you did so that you can show me, well, one, so that you have notes for yourself, but to think about what does this idea mean. Thinking is the cure to struggle. Thinking is the cure to struggles. When you think through what is happening, it will help improve your understanding. Now, quickly before we get into all these other things, so yeah, again, midterm, the midterm for y'all's Friday, the stuff we're working on yesterday, and for y'all tomorrow, that's what you'll have on the exam, plus look at your tests and other assessments. That's what you got to study. And then I do want to quickly show you the practice that y'all turned in. First off, Jay, the reason why I'm not collecting the last sheet from you is I did not actually score them because legitimately I went through them and I realized if I score this, it will drop most of your grades. You need to learn how to do these things. Like most of students, what I saw was that if we didn't get to it in class, you didn't even attempt it. So what was the point? You need practice time on your own putting these things into play. So I decided not to score it. That's a very rare thing for me. I usually will no matter what. So most of y'all should be thankful. I'll be passing them back out. But you still need to learn from the things you struggled with. And so I want you to see, bless you, that if you go on to Schoology and come back. So let's say you go to your class, for me, it brings you straight to these materials. Does anyone see anything that might help them figure out if they're doing things right or wrong? Yeah. There they are as PDFs. You will not be able to see what I've written on there unless you download the PDF. But if you download the PDF, what you will see is stuff like this. You see how I have a bunch of claims? Those equations there? What else do I have with those claims? Evidence. One, that's going to help you see what I'm expecting out of you. But two, this will explain why I did what I did, right? The same x values as the parent function, so no horizontal transformations. There's nothing underneath that square root. Each y value from the parent function table was added by 5, so a vertical translation up 5, plus 5 outside the square root. So if you're struggling with some of that stuff, those resources are on Schoology. You just got to download them so that you can see all that stuff written on there. What are your questions from here? Last detail off of here. Oh yeah, actually there's two things I want to talk about, because the next thing we're about to do is the questions from the bell ringer, and then you're just going to practice maybe some whole class discussions, we'll see. But two last things. One, I still have yet to have anyone do a retest. Guys, I can't help you if you're not going to take advantage of the help. Those retests are out. The retest is made. It's ready to go. I was absent yesterday because I was at a professional development thing. And so I decided to open up when you can do, like the amount of time you can come in for tutoring and or the retest. Remember, you just have to come and talk with me at least once during some tutoring hours to make sure that you actually learn from your mistakes, and then you can do a retest. But you have to do test corrections on everything to learn from your mistakes. The stuff that we are working on right now, the review to get ready for your 9 weeks exam, should help you improve your understanding from that first test so that you can do a retest and earn a higher score. I already told y'all, if you manage to make a B or an A on that retest, I'll wipe out the zeros or the lower grades from your homework assignments as well. Take advantage of that. Learn, grow, and improve. The last thing I want to say is this. I know that some of us struggle. And I need you to hear me on this very clearly. That's okay. Not only is it okay for you to struggle, it is good for you to struggle. Your brain is composed of a whole bunch of neurons. And those neurons send electrical signals throughout your brain as you are thinking and as you are doing things. And the only way to increase your neurons, anybody know?
Put stress on them.
Huh?
Put stress on them.
Which means you got to be using your brain. You got to be struggling. Your brain is like a muscle. Most of us are not used to flexing that muscle, and that's okay. But I also need you to understand that stress on your brain, that struggle, is the only thing that's going to actually be helpful for you long term. Because I'll go ahead and tell you, I don't imagine most of you are going to have to work with the vertex form of quadratic function for the rest of your life. I don't imagine that you will have to use the factored form of a quadratic equation for the rest of your life. Some of you might, but I did engineering. Still didn't use it a ton. I used it a little bit. Okay? What you will have to do for the rest of your life is know how to think. Learn how to make connections. Right? Math is a study of patterns and relationships, seeing how things go together. And so I want you to build those connections, and yes, it's going to be a struggle, but I'm going to be here to support you in that. Everything I do is because I care about you. Everything, even the struggles. I don't love struggle. I know you don't love struggle, but I guarantee you it'll be better for you in the long term. And also, this is why you are in small groups. If you're struggling on your own, you're going to sit there, stare at that piece of paper, and shut down. That's how that works. You struggle with a small group, you might be able to get some ideas going, which will help you grow and learn. It'll build those neurons. They'll improve in their strength. On top of that, let's say that you are struggling, but someone else isn't, and your group is not struggling. Well, they can help teach you. Which is why the first thing I'm going to ask you, if you have a question, is, hey, have you talked with your group about it yet? If the answer is no, peace, I'm out. If the answer is yes, and you're still struggling, I'll answer your question. If the answer is yes, and your whole group is struggling, bet. That's a thing I need to talk about with the whole group, because then I can help 4 people, not just 1. Alright? That's why I've designed the classroom the way I have. Talk with each other, help each other grow through that struggle, and you will become a better mathematician, a better student, a better person as a result. Because, and you haven't thought through this part yet probably, but when you have to talk with people, you learn how to build relationships better. Even people you wouldn't have necessarily hung out with before. There's a social aspect to teaching you how to be a human being in these groups as well. There's a lot of reasons why I do the things I do. Please trust me, help each other grow and work together. Now, I'm going to give y'all some time to look at the questions that you asked within the bell ringer. So let's see, no questions, bet. Creating a table from a graph, we can do that. Problems like 7 through 10, I don't understand those, can do that. Can you get a value a from a parabola? We can do that. How do you write a standard form function into vertex form? Got it. J of x table, I don't know which one that is. Don't have any I need to work on, except for 3 through 5 on the functions review. I really understand the work from yesterday. Alright. So let's look at a handful of questions, and I promise you, overall, this will help you significantly. It looks like we didn't have any questions on these tables here, and how to fill in those tables, which is good. One of the things I will point out is to just remember, right, that you need to think through, what does this operation mean? If you do that, you're good. Momar, when I look at a cube right here, what do we mean by a cube?
Like the third power.
Say again?
The third power.
Ooh, actually, that's a great thing I want to talk about. Language-wise, to help y'all out, which part, so like these are 2 different things, obviously. Which part is the power? But the exponent is the exponent, right? So this is actually something that I did not know until about 2 years ago. Like y'all see a lot of things that I know now, but that doesn't mean I always knew them. I had to learn them. So the exponent is the exponent, right? So exponent, exponent. So we need a little bit more. Does anyone know any other things that are in those expressions? The x. Does anyone know what we would call that x? It is a variable, but I mean, that's not a variable, is it? Starts with a B. It's the base. It's the base. So what in the world do we mean by a power? Well, the power is the whole thing. That's something important to be aware of. So when we say x to the third power, the power is that entire expression. So work on your language with that a little bit and be careful about details like that. The power is the whole thing. The exponent is just the exponent, and then we have the base. If you don't know that, when you start talking about this, people can get confused, and you can get confused because we're not using proper language. The language matters so that you can properly talk about things and communicate your ideas. So hopefully that's pretty straightforward. Okay? But my question to Momar was, when we say x cubed, what do we mean by that?
X times x times x.
So we're multiplying that base how many times? 3 times. Okay? That's how we get our outputs. If we have an input of -2, -2 times -2 times -2 gives me -8. Okay? Don't forget that. Kadeja, what do we mean by the absolute value over there for number 5? So we got to know that if you're going to take the absolute value, don't you? You might want to write this down. Say it one more time.
How far the number is.
How far that number is from 0. That's the only thing that an absolute value is. So Kadeja, if I give you the number 17, how far is 17 from 0? So what's the absolute value of 17? There you go. If I give you the number -5, how far is -5 from 0? It's only 5 units, right? You're never going to call up your mom and be like, hey mom, I'm -3 miles from the house. That ain't going to happen because distance is positive. -5 is 5 units from 0. So the absolute value of -5 is 5. Which is why when we do look at this absolute value, how far is -2 from 0? Well, it's 2. How far is -1 from 0? 1. Does that help clarify that? So I wasn't picking on you, I just called on you, and I'm glad that I did so that we could have that discussion for others who didn't realize it. Alright. And then don't forget number 4, what type of function is that? How do we know that's exponential? What's your evidence? Say that one more time. The x is in the exponent. That's what we want to notice, right? 2 raised to the x is in the exponent, which means we are repeatedly multiplying by, not x, 2. Aren't we?
Yeah.
Like if you were to make this table, and you were to do, so remember that's my x, so 2 to the -2, did anyone already fill this out?
And then -1/4.
It's 1/4. 1/2. 0 gives me 1, 1 gives me 2, 2 gives me 4. Notice what's happening to those y values. They're being multiplied by 2. 2 raised to the x means I'm repeatedly multiplying by 2. And so we want to recognize that. Okay. But I think 7 through 10, students had questions here. Right?
Yeah.
Yeah. Okay, number 7. I want vertex form. What do I need to do first?
Right now, vertex.
Don't make that complicated. Oh man, I want vertex form. Write down the vertex form equation. So you got to know y equals a.
X minus 8 squared.
Okay. That's it. not, and it's not it, but like you gotta recognize, okay, so what do I need for that equation? What do I need? I need my vertex. What is the vertex? That's gonna be the h comma, okay. What else do I need? I need to know what A is. Anybody know A already?
2.
That's 2. When I give you an equation, because what form is this right here? Standard. I already know the A. A is already 2. It's not always that easy, but when you start off with the equation, it is. Tamina, do you know how I'm going to find that H and K if I'm just given that equation? Yo, you got graphing calculators, don't you?
Yeah.
Yeah, let's take advantage of those things. Pick up your calculator. Let's check and make sure we understand how to do this part. So, does anybody have a question about how we're going to graph this? We good?
Me?
You okay? So are you at this page yet?
Mm-hmm.
Okay. So what's the first thing we always press to be able to do pretty much anything?
Tab.
Menu. So tab is a special case, but in general, we're going to hit menu.
Okay.
Do you see anything there, KT, that might help us graph stuff?
Number 3.
Number 3, you mean where it says graph entry / edit?
Yeah.
Oh man, we can enter some graphs there. Right? That's not making fun of you, it's just like, we want to notice, like, this thing tells us what to do.
Mm-hmm.
Now what am I going to do? Well, I need to go to function now, and I need to type in that equation. I believe, if I remember correctly from last class, it was 2x squared minus 12x. Was it plus 20?
Yeah.
There's my function.
Alright.
Now you can't ever forget what you're trying to find. I need that vertex. So, well, before we do that, so we can actually do that, but also I want to show you something else. KT, what are we always going to press to get started with pretty much anything on this calculator? Oh yeah, menu, So now one thing I just heard Preston say is that we want to add the grid in there. Does anyone remember where we can see the grids? View?
Oh, for me then view. Alright.
You see how this changes our view? And what do we want? Oh yeah, we want to add that grid to our view. And I recommend lined grid. So you can actually see that vertex without anything else. But there is another way that I want to emphasize. The minimum, right? So where do we have to go first again though? Menu. Okay? So before that, hold on. So KT, I want you to notice up here, right? Always read through all your options. KT, up here. You see graph entry / edit?
Mm-hmm.
Okay? Window / zoom. We have trace. We have analyze graph. We have table, geometry, and settings. Which of those is going to help us find different features of the graph, like the vertex?
Would it be 6?
Maybe analyze that graph.
Uh-huh.
Does it look like there's some features there?
Yep.
Yep.
I'm on it.
Specifically, our vertex in this case would be a what, since it's concave up? Minimum. Right? And so, Keyshawn, I think I saw you saying 4. Were you not holding up number 4? Oh, never mind that. Alright, so, oh, by the way, 0, what would that help us find? Those roots. Remember, the zeros help us find the x-intercepts, which are how we identify those roots. But minimum, remember, lower bound just means it needs to be to the left, upper bound to the right, and does that give us our vertex? Heck yeah. Notice, and we want to clearly identify these things as part of our justification. So 3, 2, so I am showing that h is 3, k is 2. So x minus 3 squared plus 2. That's it. That's how we do this. Y'all remember that showing up on your test?
No.
It did. If you're going to do a retest, this might be super helpful for you. Okay? I would recommend it. Might help you do test corrections as well. Now, I want to point this out because someone in second block did ask, well, but Mr. Kinney, why, and I think it's on these directions where I tell you, hey, give me the, stop and pay attention. I'm just kidding, but I need you to pay attention to this. They asked, why do you ask for the transformations in vertex form but not in factored form? And so I do want you to see, like, I'm not ever going to ask you for transformations in factored form. So vertex form is a times x minus h squared plus k. And factored form is this. So why am I going to ask you for transformations here but not here?
Repeat that.
Why am I going to ask you for transformations from this form but not from this form?
Probably because
So this does focus on the roots.
why?
Okay, kind of. Let me remind you of this. When we talk about transformations, it's always from the parent function. What's the parent function? So y equals x squared. So where do we more easily see those transformations? The first one, right? Horizontal translation, vertical translation, vertical dilations and reflections. Here, there's no vertex, but also it's not just that. Literally what we're doing is we are taking, does anyone know what type of function that on its own would be? Just x minus r1. Like if you had that, anyone know what that would look like? That would be a line. So I am taking a line and I'm dilating it by a line. That's why I'm not asking you to do those transformations. Okay? Because I'm looking for the transformations of that parent function here. Which we started to do this recently, but we haven't done a lot with it. So that's why I'm not asking for the transformations out of this factored form. If you have that question, I hope that answers it. I don't think anyone had a question about these tables. Is that correct? If I'm wrong, please correct me. I think some people had questions about these graphs on the back. Does that sound accurate?
Yes.
Should we go over at least one of these?
Yes.
Yes. So, remember, I've given you options here. I just told you this is quadratic. So what can you do?
Write down the quadratic equation.
Okay, but which one? How many quadratic equations do we have?
3.
We have 3 of them, right? Which one?
I got some stuff.
So, in order to do vertex form, we need the vertex, okay? And then, Momar, I think you said factored form? So for factored form, what do I need? The what? The x-intercepts or the 2 roots, right? So, I will point this out. Do you see a vertex?
Yes.
Yes. It's not on a clear intersection of grids. So you could do vertex form, but it might be a little bit harder. Do I have clear roots? Yes. Negative 2 comma 0. 3 comma 0. Notice this is just like numbers 7 through 10, except for one small difference. We would have to find the a. Notice if I'm going to use, so I'm going to use this factored form. What is R1? The negative 2. What's R2?
3.
Okay. So I've got like half the work done. Not really, but I have like half the equation.
Mr. Kenny, I got a question. Would it matter if it was switched?
Nope.
Oh, okay.
And that's a good question, but like think about it. Negative 2 times 3, is that the same thing as 3 times negative 2?
Yes.
Yeah. So the order that you multiply in doesn't matter. Okay. So x and then what? Plus 2 times?
X minus 3.
And so remember, we originally just talked about it because it's minus R1 and we always need the opposite, or the opposite. But also notice, aren't these horizontal transformations of a sort? So we need the additive inverse, right? So it's all connections. That's what we want to notice. But Tracy, you made a great point. what do I not have?
The A.
The A. When I give you the equation, you already have the A. Here, I ain't got it. So what do I need to do? You need another point. I want y'all to take 30 seconds, look at the graph, identify some points there. So look at that graph, identify some points that we might want to use. Do you have the sheet, Jean?
Yes.
Really? What did you do yesterday? Did you work on the other one?
I did it.
That's what good.
I worked on it.
What book was you reading?
You must be right outside your mind.
I just had one,
Yeah,
I just had one job.
Mackenzie, can you tell me a point that we could use?
Called it like,
What was the question?
Can you tell me a point that we could use up here to help find A? What'd you do for those 30 seconds?
I
Zero
get
12.
it. I got.
What'd you get?
-2 for A.
What'd you say?
-2.
Oh no, I'm asking you, just in general, what is a point on the graph that we can use to help us find A? What'd you get, Keyshawn?
0, -12.
0, -12.
I got it too.
Got that too, did, anybody get a different point we could use?
2 negative 8.
1, comma -12,
Yeah, 2 negative 8.
2, -8,
One negative 8. Negative 1 negative
and -1, -8. So, does it matter which point we use? Heck no. There is one point I would recommend.
0, 2.
0, -12. Do you know why?
Because it's the vertex.
It is the y-intercept, but more importantly, the x value is what?
0.
Yeah, if I can use a 0, bet money all day. It's easy. Okay? So, remember, one way to think about this is, yes, this is the point 0, -12. But in function notation, f of 0 is equal to what?
Why?
It is a y value, but it's not equal to 0. It's f of 0, meaning if I substitute 0 in, what am I getting out?
12.
The y value, which is -12. We want to notice that function notation. F of 0 is equal to -12. That's just this point in function notation form. So what's going to be substituted in for this f of 0 for the f of x? Equals a times. Man, that's lovely, because what's 0 plus 2? 2. What's 0 minus 3?
Negative 3.
-3. So we want to notice all these things are being multiplied. So -12 is equal to a times
-6.
-6. Be careful and remember, if you need to show the dot in between to indicate multiplication, okay? A times -6. Last step. Hmm? You can do, like, rewrite it. You don't have to rewrite it. You can divide by -6, but what am I recommending that you do instead? Multiplicative inverse. Times 1 divided by -6. And I know that y'all think I'm crazy for this, but has anybody started to realize why I want you to use the multiplicative inverse instead? Have you seen it show up anywhere else that might be super important?
Seeing the multiplicative inverse.
Yeah, have we seen that show up anywhere else where it's really important? Where?
On the tape.
Yeah, that's actually one of the big ones, right? If we were looking at this function right here, let's say 36, -2, 18, -1, 9, 0, 9 halves, 1, 9/4.
Times 1 divided by 2.
Yeah, if you write this as division by 2, that's okay, but does the exponential equation allow for division easily?
No.
But how can I rewrite that division by 2?
Times 1 half.
So is that multiplicative inverse kind of important?
Yes.
And if you're used to doing it here, will it help you see it here? If I give you this equation, what's the scale factor for this dilation here? How'd you get that? Well, it's the multiplicative inverse. I need you to understand, like, I know things that are coming up, so when I recommend something, it's not to make you do more work, it's to help actually build stronger foundation so that when you get to other stuff, it's easier. Okay? There's connections all the way through. I don't want to teach you one thing to get you through a test. I want to teach an enduring principle that continues to work over and over and over again. Right? Strong foundations that you can consistently use. That's why I want you to do this. And don't forget, the reason why we use the multiplicative inverse is because we're trying to create what number?
A 1.
A 1. We're always trying to create ones or zeros, and you need to pay attention to when we adding or multiplying, and then use a calculator or just negative 12 times 1. Negative 12. Negative 12 divided by negative 6.
2.
Now Mackenzie, I want you to notice, didn't you say earlier A was negative 2?
Yeah.
Yeah. Is it? So we need to be careful. 1, 2. Can anyone look at that graph right away and tell me why we should just think and say, wait, I made a mistake? If you got A equals negative 2.
Because it's supposed to be positive because it's concave over.
We want to pay attention to that. If you get an A of negative 2, that graph should be going down, is it? Is that graph going down, concave down?
No.
No, so we shouldn't have gotten a negative 2. So we need to go back and fix our mistakes. Look to see where there is a mistake. Alright? Slow down and think through what you're doing. Alright. That's where I'm pausing for whole class discussions. Unless are there any burning questions that I have not answered yet? I think I hit them all. What you got, Caleb? Are you sure, or are you about to ask me a question as soon as I let y'all go into small groups?
No.
Okay. Any other burning questions? Yes, sir.
How was your day yesterday?
Honestly, in the kindest way possible,
Yeah.
it was a little nice to have a break from students, just like I'm sure it was nice for y'all to have a break from me. However, I did miss y'all at the same time. I like teaching.
I'm sorry, I have to break the ice.
Well, so remember, it's the multiplicative inverse. This negative 6 is understood to be divided by 1. And the reciprocal is what we have there, right? And so you can actually use this in really powerful ways. If I had this, right? Instead of dividing by negative 2/3, because dividing by negative 2/3 would be a pain in the butt, I can just multiply by the multiplicative inverse, the reciprocal. The multiplicative inverse always creates a 1. So that actually speeds your process up significantly. Does that make sense?
Second part, you just times it by. We have it 12 times.
Yeah, that's it. And what you can do, and I will point this out, so Jakeem asked you a question about like this idea of using that inverse. So remember the multiplicative inverse, it's just the reciprocal. The numerator and denominator switch, right? And you can multiply over here negative 12 times negative 3, which would give me, anybody?
36.
36. And then what does this fraction bar mean again? Division? You mean it's not just like randomly over something? No, it means division. 36 divided by 2 would be 18. It's okay. So what I want to emphasize and point out here is an easier way to do that is division can come first. What's negative 12 divided by 2? Negative 6. What's negative 3 times negative 6?
18.
That same 18, isn't it? So remember, multiplication and division are just inverses of each other, but they happen at the same time. You can do the division first. Whatever makes your life easier. Does that make sense, Jakeem? Okay. So, if y'all have not finished, you can continue to work on those problems there. One thing I will make a note of is, I will, just like I showed y'all the solutions for all that practice earlier, I'm going to make solutions for all of this and upload it onto Schoology so you can use that to help you study and check your answers. You can email me questions if you have any. I'll try to show my evidence as well as possible for any claims I make. What I would recommend, except maybe one of these if you know that you need practice with it, I would recommend moving on to these problems on that second packet you got. Your job is to what?
Learn and grow
How are you gonna learn and grow the best though?
in your small group by talking.
By actively collaborating, by talking with each other. You finish a problem, you check in with your group and see if they got the same answer, because if y'all got different answers, y'all need to hash it out. You need to talk it through, and if you can't come to a consensus, Miss Courtney or I can help you figure out who's right, who's wrong, if we're both wrong, or if they're equivalent, just looking at it different ways. You need to talk through ideas if you're struggling, ask questions of each other, and help each other grow and learn. Alright, are we clear on what I'm expecting us to do? Let's get to work. Caleb was just, no, I'm just kidding, I'm never clear on what I'm doing. Hold on 1 second. It's already done. You can tear it out, put it on top of my laptop. Yes, ma'am. Number 2? Or 3 through 5? Have y'all talked about numbers 3 through 5 at all on this sheet? You just looked at it? Okay, have you talked to your group at all yet? So, Mackenzie has questions on numbers 3 through 5. Let's look at those together. I'll come back and answer questions if we get stuck completely and we don't have an answer. Okay? So I'll help you after y'all talk. On the book. Wait, you already done 2 through 4? You know I didn't ask you to do number 1, right? No, it's just numbers 2 through 4. There's a reason why I didn't ask y'all to do number 1. Things that we haven't covered well yet.